Today we're going to talk about more statistic stuff. We're going to talk about confidence intervals. Okay, so confidence intervals. There's two words in there, confidence and interval. Turn to your neighbors and tell them what the definition of what confidence. What do you think confidence means? And then ask them, what do you think interval means? Okay.
Confidence is to make sure you're confident. Interval or short intervals or periods of time. Interval, like when you're like. So what we can assume from that term is we can assume that there's any intervals that are for sure going to be happening. You can say they would be fixed intervals. You can say they might vary depending on what the lesson involves. So.
Okay, so what does confidence mean?
To be sure in yourself or someone.
Okay, let's bring it back together, please. Okay, what does confidence mean?
To be sure of something.
To be sure of something. Do you agree with that? Is confidence to be sure of something?
Yeah.
Yeah, I think that's pretty good. Any other? Feel good about? That's good. I like that. So confidence is when you feel good about yourself or feel good about something. To be sure of something. Excellent. What is interval?
A period of time.
Okay, it could be a period of time. That's not the only thing. What else is an interval?
A period of something.
What else?
A set standard or statistic for
Okay. Now let's think about. Raise your hand if you're an athlete and you've done interval training. What's interval training? It's bust? Okay, yeah, it is bust sometimes. Yep. You just said bust. Isn't that what you said? Okay. Yeah, it's tough, right? It's when your coach is like, okay, when I blow the whistle, when your coach blows the whistle, you're going to sprint for 30 seconds. And then when they're going to blow the whistle after the 30 seconds, you're going to do push-ups for 30 seconds. And then they're going to blow the whistle again, and then you're going to do sit-ups for 30 seconds. And then you're going to blow the whistle again, and then they're going to do something else, and then you repeat it, right? You do different exercises for intervals, right? Okay, raise your hand if you've done interval training, if that sounds familiar. Okay? You have a range of time you do something. So we're going to talk about confidence intervals, and in the sense of like, let's say I do an experiment. Okay, let's say I'm a doctor or a researcher, and I'm making pills. Okay, so are you going to take pills that are not tested?
Yeah.
No.
I'll be the tester.
It depends on who they're tested on.
Get a prompt part 2 off those. Come on.
Okay, so an example of this is like when they come up with a medicine, they test it on people or even on mice, unfortunately. Okay, animals sometimes. And they want to make sure that it tests correctly. They want to have a positive outcome. And so they'll test it to make sure that it has a high percentage of success. And then they also apply this thing called a confidence interval, because they'll say, if we repeat this same test with the same pill to the same, or to people, we want to make sure it has the same outcome, right? Because what happens if you have a very dangerous medicine and it does not help you? Let's say they make a medicine out of like, oh, I made a medicine today. I made it out of rat poison and bleach and then dog food, and I put it in water and boiled it. There you go. It's going to make you feel better. Yeah. Okay, would you have the medicine? Yeah.
What are the benefits?
Did you try it on yourself? Did you try it on yourself? Yeah. Okay, so, listen up. Maybe I tried it on myself and I felt better, right? But maybe it doesn't help everyone feel better. So we do this thing, we have a high confidence interval when we work with medicine, but what we're talking about today is if we do an experiment, how likely is it to repeat when we do it for someone else, okay? So that's what confidence interval is. Here are the steps. And what I'd like you to do right now, if you're on the computer or on the video, you need to take a picture of this blue thing. So can we all take a picture of this with our phones? Because you need this for your homework. Okay? I'm going to pause the video here while you do that. Okay, so you should have this down. these are important because we want to be, on certain tests, we don't really care to be confident. Like, I care to be confident that my medicine works every time, right? It's not, but I don't need to be necessarily as confident about certain data. Like, I don't need to know, like, be confident about the average of people, sizes in some instances, because it doesn't matter to me. And so we have different confidence intervals here on the left, and their corresponding z-score. You need to know what z-score to use in order to do this, okay? So we're going to calculate it, and I'm going to tell you what it means. Here we go. So, number one. Let's say we measure the heights of 40 randomly chosen men and get a mean height of 175 centimeters and a standard deviation of 20 centimeters. Okay? Eyes up here. Eyes up here. Let me get through this. Okay? So let's just say I was a kinesiology professor. Anyone going to go into kinesiology? Like, okay? It's like a sport. You are. It's a degree where you understand people's physical, mechanical movement, and you know how to. It's like it gets you into physical therapy.
So I can have a trainer.
You could be a trainer. You could be a physical therapist. Yeah. Okay. So kinesiology, let's say I was your professor. It's like, hey, I want you to go measure 40 random people. This is how you do it. I'll model it for you. And so I measure 40 men, okay? And I get an average height of 175 and a standard deviation of 20. What is the confidence interval, okay? And let's just say I want to use a 95% confidence interval, okay? So I'll say, I'm going to show you how to do it with a 95% confidence interval. So I'm going to go back to this chart, and I want to focus on 95%. What's the decimal point at 95%, or the z-score?
1.96.
1.96. So let's keep that in the back of our head, and we're going to go start with the confidence interval expression, which X with a little line above it, that means mean, okay? That represents average or mean of a sample. So we got the mean is plus or minus. The mean in this example is going to be 175. And our standard deviation, S, is going to be 20, okay? Or you could use the little sideways symbol like that. That's also standard deviation, okay? And we want to start with a 95% confidence interval. So I'm going to start on step 3. We have the mean plus or minus the z-score, go a little faster here, times the standard deviation all over the square root of the sample. So this is, don't worry about how we created this, you just need to know how to use it if it's presented, okay? So I'm just going to input the numbers. The mean in this example is 175, plus or minus our z-score is 1.96, times the standard deviation in this case is 20 all over our our sample size of 40, square root of that, and then I'm going to go to my calculator. So let's all pull out your calculator so you can practice it. Here we go. Okay, whether you use your phone or this, you just need to know how to do it. Okay, so I'm doing PEMDAS. There's some parentheses right here. You got 20 divided by the square root of 40 equals, I get 3.16, and then I'm going to multiply that times 1.96, and then I'm going to get this number on the right. And notice I have a plus or minus, so I'm going to do 175 plus this number, and 175 minus this number. So I'm going to write that down just so I have that handy. Okay, and then I'm going to figure it out. 175 plus 6.198 in my calculator is going to be 181.2, I'll round, and then 175 minus 6.198 is about 168, okay? So what is this telling me, okay? So let's think about the experiment again. I'm a professor. I was measuring the heights of men, okay? What was the average I got?
175.
175. How many people did I measure?
40.
What was the standard deviation? 20. Okay, what does this mean? It means I could be 95% confident, almost fully confident, but there might be some variation. I can be 95% confident that if any of you, as my students, did the exact same experiment and randomly selected 40 men, you would get an average that is in between 168 and 181. Okay? Does that make sense? So let's just say, who are my kinesiology bound people? Any of you? Was it you?
John.
You're going to go into veterinary medicine.
Yeah.
John? Who was it?
John.
Where's John? Oh, Jonathan. Oh, okay. Okay, let's say any of you are going to do this experiment again. This is what your average would be. Does that make sense? Okay? So now let's just say as a professor, I was like, hey, you know what? I want to be a little bit more confident. What number is more confident than 95%? 100 is the best, but we can never be perfect. So 99 or 99.9. So let's use a different confidence interval. Let's use the next one, which is going to be 99%, okay? Wouldn't you agree that 99% is more confidence than 95%?
Yeah.
Okay, good. Okay, so now I'm going to go back to my table, so you pull that up on your phones if you have it. Okay, looking at 99%, what is the z-score for 99%?
2.576.
Okay, 2.576. So we're going to go back to our problem here. And I want to do the same calculation, but with a 99% confidence interval. So I'm just going to plug in my numbers. 175 plus or minus 2.576. That's our z-score times our standard deviation of 20 all over the square root of our sample. Okay, and then we go back to our calculator. And when I calculate this out, I'm going to do the parentheses again. We got 20 divided by the square root of 40. It's going to be 3.16 times 2.576. And I get a number 8.14, or 8.1, I'll round in this case. So I know my confidence interval will be between 175 plus or minus 8.1. And when you do that, you get this range here. Now when I talk to you as my students, I'll say, hey, when you redo my experiment on your own, I could be 99% confident that you would get a range that's between 166.9 and 183.1 as your average. Does that make sense?
Yeah.
Okay, so is this new range, possible range, bigger or smaller than the original 95%?
It's wider.
It's wider, right? Why do you think it's wider if I have an increase in confidence?
Maybe more subjects, maybe more testings, maybe the more to prove.
Think about the story. What am I talking about?
The heights.
What am I measuring?
You tested more people, you get more better average.
What's the topic today? What's the first word in our topic? It starts with a C.
Centimeters.
Confidence, right?
Oh.
Thank you. Confidence. If I want to be more confident, wouldn't I want to widen my range to include more numbers?
Yeah.
Right? When I'm less confident, my range is going to shrink. But it's like, well, I'm less confident because I don't know if it's going to fit in here. Okay? But I could be more confident, I could fit more numbers or possibilities, right? So that's why it's wider. Okay, so all we're doing today, confidence interval, is we're saying, hey, I'm confident that if you redo my experiment, your new average will fit someplace between these two numbers. I'm 99% confident. Okay? Number 2, let's do this again. Number 2, let's say I was interested in understanding who goes to buy Chevy cars. Okay, let's say I was in marketing. Okay, I was a marketing consultant for Chevy. Okay, and that could be one of you. Let's say Chevy's all like, man, we're not selling enough cars. We keep marketing to these young kids to buy our Chevys in high school, and they don't really come to our store. Okay, and you're like, all right, let me go do some surveying. Okay, so they're like, sure. And then so they give you permission. You're at the Chevy dealer on a Sunday, okay? And you ask people, all the people that come in all day. Okay, you end up asking 100 people, and you went to the Chevy dealer, and their mean age you figured out was 47. 47 with a standard deviation of 3.3. Okay, so that's what you figured out. So you're going to figure out what can you report to the Chevy dealer. What can they do if they do this test again? Okay. Well, they really only care about a 95% confidence interval, so you could tell the Chevy dealer, like, hey, you know what? If you do this test again next Sunday on your own, you should get a range. And let me tell you what that range is of a new average.
Wider age group?
Of what their age group is, yes.
Yeah.
Okay, so we're going to go to 95% back on our chart here. What's the decimal for 95% confidence interval? Z-score? Good, 1.960. Okay. So I'm going to start by writing down my my confidence interval expression and start filling in the information. So we got 47 plus or minus the z-score, all times our standard deviation, divided by the square root of our sample size. Okay, and then we go to our calculator. And when you do that, you'll get 47 plus or minus 0.646. Okay, and then when you add and subtract from 47, you get this range here. 46.354 to 47.646. Okay, is this a very wide range if we're talking about ages? No, it's not, right? So as a marketing consultant, I'll say, hey, you know what? I know you really care about marketing to kids, but you know who's actually coming to your Chevy dealer? What age? 40-year-olds, right? Late 40-year-olds, right? I don't know if this is actual, but so the boss and the marketing team at Chevy is not going to like make videos of little kids driving Chevys around. What do you think they're going to do?
Older man.
Yeah, they're going to have like the middle-aged man, you know, like, oh, living your young life again in a Chevy.
Midlife crisis.
Cobalt. Okay, or whatever, right? So, Impala. The old Impalas are pretty cool. The new ones are kind of not really that. Okay. Okay, so again, I'm 95% confident that if someone redid this experiment, that their new average would be here. Now, since it's so little, why do you think this range is so small where number one was so wide? Think about what we learned the other day with standard deviation. Why do you think this range is smaller and for number one it's a lot bigger? Talk to your neighbors. What does standard deviation have to do with anything?
It's 3.3. It was 20 in the other one. So the smaller the number, the smaller the gap that will be. That's why I became
Okay.
20 was a wider number.
So standard deviation talked about how normal something was, right? The closer you were to the center, the more normal you were. Remember that?
Yeah.
And how many percent of all people are across the whole standard deviation normal curve? 100%. And right in the middle we have our average. In this case, for number two, our average is 47, right?
Yeah.
Our standard deviation here was 3.3, right? So if it was 3.3, let me fix this again. If it's 3.3, that would mean this is 50.3, and over here we have 43.7, right? So the normal age range of people that come to the Chevy dealer, normally, over 2/3 of people are going to be from 43.7 to 50-year-olds. Does that make sense?
Yes.
Now what happens if my standard deviation changed from 3 to 5? Okay, so let's switch this up. Look at what happens when our standard deviation changes.
It decreases by a lot.
Look at the range of normal in the middle. Are there more people that are all of a sudden normal?
Yeah.
Yeah, exactly. You see that? So, standard deviation is super important and affects it. So, let's talk about a little review. Standard deviation has to do with what's normal, okay? If you're in the middle, you are normal. You're part of the population. If you're below normal, you're out on the edge. Or if you're above normal, you're way above the edge. Whatever it is, okay? Sometimes being below normal is better. Sometimes being above normal is better. Okay? So that's standard deviation. Yesterday we talked about margin of error. Remember that example with Trump? Yes? So that has to do with you being critical of a study. Like, can we trust a study that said that they only sampled 1,111 people to predict that Trump is favored? Was that a good survey? Did they do a good survey? Why or why not? Isn't 1,100 people a ton of people?
Yeah.
It is a lot of people. But what's wrong with the survey? There's way more people in the United States, so it's not representative, right? So margin of error gives us a bit of how to critique a study. This tells us, like, if you're doing a study and someone's going to replicate it, how confident are you that it's going to happen again? Okay? That's all. A lot of analytical stuff, but that's it.